Hi, this is Miss Logan. Today we will continue our talk on the kinematic equations, but instead of applying them to the horizontal direction, we will be applying them to the vertical direction, so that's up and down. So, as a reminder, gravity is a force that attracts massive objects towards one another. On Earth, gravity causes everything to accelerate at a constant rate of 9.8 meters per second downwards. That's also known as negative 9.8 meters per second squared. When we are working with things in the vertical direction, this will be our acceleration every single time. It'll always be negative, and it'll always be 9.8 meters per second squared. As a note, direction is extremely important when we are solving these vertical motion problems. It's really easy to read a problem and think that it's all in the positive direction when in fact most of it is in the negative direction. We will be using the exact same kinematic equations as before. So our first one is the distance is 1/2 times the acceleration, which is just going to be gravity, t squared, plus the initial velocity times time. Our second one is the final velocity equals the acceleration, which will be gravity every time, times time, plus the initial velocity. Our final one is the final velocity squared plus 2g instead of acceleration times d plus the initial velocity squared. The only difference between these kinematic equations and the kinematic equations we use in the horizontal direction is that the acceleration is g every single time. Alright, so let's apply these equations to practice problems. So while Anne is on her cell phone while laying down in bed, she accidentally drops it on her face. How fast is the phone going if she held it at arm's length away, which is about 0.75 meters? If you notice, there's not a lot of things given in this problem, which may give you a big question mark. So before we actually solve this problem, let's talk about what a projectile or something that is only moving in the vertical direction looks like. So let's say I'm throwing some ball with some initial velocity, and I start it from some 0 point, okay? So I'm going to have some initial velocity, okay? And just so we have some numbers for some reference, let's say I release it with 3 meters per second. As we probably know, if I throw it up in the air, it's going to reach some top point. At this point, for that second in time, our velocity is going to equal 0. Okay? This is the first part of our equation. Okay? We have some initial velocity and then a final velocity of 0. In this time, we went some time, and we also went some distance. This ball, which is now up here, is going to travel back down. We know that the time is also going to be the same, and same with the distance. So, if I find the time going up, I know it's the same going down. We're going to use that in some of our equations today. So let's revisit this problem. Anne is laying on her bed, her phone is still, and then she drops it on her face, and it's traveling about 0.75 meters down. Okay, so before I actually solve this, let's draw this out. So her cell phone is starting up here, and it is falling down onto her face right here. So we know that the distance traveled is 0.75 meters. But remember, it's traveling down. It's traveling negative. So it's actually going to be negative 0.75 meters. We also know her initial velocity is 0. She's holding it still. Her acceleration is gravity, which is negative 9.8 meters per second squared. What are we looking for? We're looking for the final velocity as it hits her face. So our equation we're going to use is VF squared 2 times A times D plus V0 squared. Let's put all of our numbers in. We're looking for VF squared 2 times negative 9.8 times negative 0.75 plus 0. So I am going to get VF equals 3.83. Remember, I took the square root on both sides. And we have meters per second. All right, let's do another practice problem. So Eric kicks a soccer ball straight upwards with an initial velocity of 25 meters per second. How much time does it take before it reaches the ground again? So we need to figure out the time as it goes up. Let's talk about what we know. So the only thing that's explicitly given in the problem is that the initial velocity is 25 meters per second. But we know a couple other things. At the very top of the projectile, it's 0 meters per second. My acceleration is negative 9.8 meters per second squared. What am I looking for? I'm looking for time. So I can use VF equals VI plus AT. And I'm solving for t. So I'll have VF minus V1 over A equals t. Now it's really important that we carefully plug in our numbers here. So we have 0 minus 25 or negative 9.8. Now, you'll notice that my negatives cancel out, and I want this to happen. I cannot have negative time. That's not a thing. So if my answer for time is negative, something's wrong. So the total time it takes it to go up is 2.55 seconds. But I'm looking for the total time up and down. We talked about earlier, the time up is also same as the time going down. So all I have to do is multiply this by 2. So I'll get 5.1 total seconds.